Hello everyone, this question has been taken from Irodov, Fundamental Equation of Dynamics, question number 68. The question says, at the moment t is equal to 0, the force F is equal to AT is applied to a small body of mass m resting on a smooth horizontal plane. A is a constant. This A is a constant. The permanent direction of the force makes an angle alpha with the horizontal. Find the velocity of the body at the moments of its breaking off the plane. Means velocity of the object or the mass or the body when it comes out of the plane. So at that time, what was the velocity? And second, the distance traversed by the body up to this moment. At that instant, how much distance it covered? So let us solve this question. Here all forces have been shown on mass on the body. One is gravitational pull mg, n is the reaction force from the plane to the body, F is the force. We have taken the component in the horizontal direction of this force as F cos alpha, and this will be the F sin alpha. For our convenience, we have taken y-axis vertical and x-axis in the horizontal direction. And let us notate acceleration by w in the x direction. We are interested in knowing only till the time the body is running on horizontal plane in the horizontal direction and the moment at which it breaks off, means just lift off from the plane. Okay, so applying Newton's law of motion in y direction for this body, F sin alpha is the vertical force, the component of this force acting in the vertical direction, in the y direction. N is also acting in the y direction. Mg is acting in the negative y direction. Volume mass into acceleration in the y direction. But acceleration in the y direction will be 0 till the time it breaks off. Till the time the body breaks off from the plane. So we'll put the value. So we have got this equation 1, AT sin alpha plus n minus mg is equal to 0. Number 1 equation. And let us say that T subscript B be the time at which the body break off from the ground. At this instant, the normal reaction force N will be 0 because the body is no more in contact with the ground or plane. Using equation 1. So in this equation, if we put this 0, so we will get TB here, right? So A into TB into sine alpha plus 0 minus mg is equal to 0. This is small a, so you can correct while you writing on your paper. Hence TB will be mg by A sine alpha. This is equation number 2. W is the acceleration in the x direction as we have taken. So applying NLM in the x direction, F cos alpha, this is only force acting in the x direction is the F cos alpha is equal to m into W. So W will be AT cos alpha by m. This is equation 3. Now we know that the acceleration is dv by dt at any instant. So this is equation 4. So using equation 2 and 3, dv by dt will be AT cos alpha divided by m, right? So dv will be this. Integrate both sides. V is variable, T is variable, rest all others are constant. So constant we are keeping outside. So dV at any instant t, which is below, which is less than tb, we should consider that at any instant t, this velocity of the body was v. It started with a zero velocity, so from 0 to v, you are integrating on the left side. And t started when the v was 0, so from 0 to t time we have taken. After integrating, we got the equation this: a cos alpha by m t square by 2 at any instant of time t. Now we are interested in knowing that what was the velocity when t was tb. So in place of t, we will be writing tb. So this equation you got. Put the value of tb from equation 2. So we will be getting this. So this is one of your answer, the part A. We further know that v is ds by dt at any instant, right? And from this equation, from equation 4, we will put this, the value of v at any instant. So a cos alpha by m t square by 2 from equation 4. Integrate both sides. The starting point, the reference we take at 0, and at any time t we take it at, it has covered a distance s or displacement x. Okay, this part is constant, so we have kept it outside. So 0 to t, t square into dt. So after integrating, we got this, a cos alpha divided by 2m tq by 3. We want to know what was the displacement at time t is equal to tb. So we will put in place of t, we will be putting tb, and tb from equation 2, we will put the value of tb. So we will be getting this. So this calculation is for you. So you can do this, a simple calculation, and you can do it. So you'll be getting s is equal to m square gq cos alpha divided by 6a square into sin alpha cube. So hopefully the concept of solving is clear to you. In case of any doubt, please do let me know through the comment. Thank you.